Hello, welcome back. Today we will be studying about applications of the dot and cross product, and also we will be doing some more exercises. We have seen what the dot and what the cross product is, okay, and we have also seen some of the properties. But now let us take a look at the applications. The applications that we will be doing right now, okay, they are only geometrical applications, okay, but some more applications we will do, okay, towards the end of this semester. All right, so let's see. Okay, so the first application, the first one is finding the area of a triangle. Okay, so we will find the area of the triangle, but by using dot product, and the second one we will use the cross product. Okay, so A by using dot product. So what we will do, okay, if we have to use a dot product, it means that we will try to derive a formula for the area of a triangle which involves the dot product. Okay, so what we will do, we will need a triangle first of all. Okay, so let this be the triangle ABC. What we will do, area of triangle ABC. Okay, the usual formula, it is half times the base, which is BC, times, okay, I won't be using the dot over here, but just know that it is there. So instead I will write in brackets half base into the altitude. Okay, maybe AB. Okay, so this is the formula for the triangle. The area of the triangle is given by this formula. So now we want to use vectors. So I will name this vector BC. Okay, I will let it be a vector. So I will just include this arrow. And over here AB, I will use this arrow. Okay, maybe it's best. It is best if we take this one as A, B, and C. It doesn't matter. Again, just for the sake of convenience. Okay, so the formula for here will be AB, okay, CB. Okay, so it will be half AB. Okay, we can write it as magnitude of the vector AB. Okay, so nothing yet. Okay, but CP, I will express it in terms of this vector AC. If you see, if this angle is theta, so CP, it can be written as AC sine theta. That is clear. So CP, it can be written as AC sine theta. Again, I will be using vectors, so that's why I'm writing it as AB, AC sine theta. But we are using the dot product, so sine, we will convert it into cos. So root over 1 minus cos square theta. This is how we convert sine into cos. Now, we want to use the dot product again. So we have got cos. If you remember, how much is AB dot AC? The formula for AB dot AC, it is magnitude AB, magnitude AC, cos theta. Why am I doing this? Because again, I want to use the dot product. So I've got cos. So cos, it can be written as AB dot AC divided by AB AC. So this is what we got the value of cos, but we have to square it. Okay, we can simplify it. Okay, we can simplify this one. So what we will be getting is AB AC root over AB AC, again holding square, minus AB dot AC holding square divided by magnitude AB AC, again holding square. So this is what we have. Okay, we can take the square root of this one, so it will get cancelled with this. So ultimately we are left with the area of triangle. Ultimately we will be having this formula: half root over AB AC holding square, because both of them they are magnitude, so we can write it like this, minus AB dot AC holding square. So this is the required formula for the triangle by using the dot product. Okay, as you can see, it's very simple. Okay, when we are doing exercises, okay, it will become clearer. Okay, that this is in fact a very simple formula. But there is an even more simpler formula which we will be using, and that is by using the cross product. Okay, you can try to remember this one, or if you cannot remember this one, you can surely remember the second one by using the cross product. Okay, again we will be needing a triangle. Again the same thing, ABC, this vector, the angle between the two vectors is theta. Again we will be needing the magnitude CP. So area of triangle ABC, it's equal to half AB into CP, it's equal to half AB CP. It can be written as AC sine theta. But if you see, this one is already the formula for the cross product. Okay, we just have to make some modifications to it. We will put magnitude, because as you can see over here, this one, it is a scalar quantity. But if we want to use vector product, okay, vector product, it is a vector quantity. So to make adjustments to it, we will be putting everything inside the magnitude symbol. Okay, AB cross AC. If you see this formula, AB cross AC, it is magnitude AB, magnitude AC, sine theta, n cap. Right? So if you take the magnitude, we will be having magnitude all throughout. Magnitude remains as it is. Magnitude of this one remains as it is. Sine theta is a scalar, it remains as it is. But the magnitude of n cap, it is 1, because it is a unit vector. So that is why we can have this formula. So as you can see, you can even use this formula. Okay, do not worry. Again, when we are doing the examples, it will become clearer how we can use this one to evaluate the area of a triangle. Okay, so the second application is finding the area of a parallelogram. Okay, if we are finding the area of parallelogram, so we will need a parallelogram. CD. So as you can see, solution, area parallelogram ABCD is equal to 2 times the area of triangle ABC, 2 times area triangle ABC. So we can just substitute the area of triangle ABC, which we have it as this one, AB cross AC. So that is how we can evaluate. Okay, which is just AB cross AC. So you can easily remember this formula as well. Okay, it's not very complicated. So we can find the area of a triangle, we can find the area of a parallelogram. What else can we do? Okay, the third application, proving that 3 points are collinear. Okay, 3 points are collinear if they all lie in a straight line. Okay, so if these are the 3 points, if you can draw a single line that passes through them, then that will be collinear. So what can we use over here? Over here we can see that if the 3 points do not lie in a straight line, in a single straight line, you can form a triangle. But if all of them, they lie in the same straight line, you cannot form a triangle. In other words, the area of a triangle will be 0 if the 3 points are collinear. Solution. Okay, I won't be using solution. I will just say AB and C, the points A, B and C are collinear if area triangle ABC equal to 0. That is, if half times AB cross AC is equal to 0. Alright, so we can just use this one to see that the 3 points are collinear. Okay, so now that we have done these applications, okay, there will be some more that we will do towards the end, but now let us just see some exercises based on this. Okay, so how will we do it? Okay, question, find the area of triangle ABC where A is a point, okay, maybe 1, 0, 1, B is 0, 2, 0, and C is 1, 2, 3. Okay, just some random points that I've given. So if you can see, okay, we can use the Cartesian plane. It doesn't matter, alright, I will just be approximating the points, okay, maybe they lie somewhere. Okay, so we don't even need this figure. Okay, we can just straight up draw the 3 points A, B and C. Okay, so let them lie in a triangle like this. So now we just find the solution. Okay, so we can find the area of triangle, but we will need this vector. Okay, so the vector AB, how much is it? The vector AB, it will be the position vector of this one minus the position vector of this one. 0 minus 1 will give you minus 1 I. 2 minus 0, it will give you plus 2j. And similarly, 0 minus 1 will give you minus k. So this is how we find the vector AB. How are we going to find the vector AC? In a similar way, 1 minus 1 will give you 0i. 2 minus 0 will give you 2j. 3 minus 1 will give you plus 2k. So this is all that we need to find the area of the triangle. Therefore, area triangle ABC is equal to half the magnitude AB cross AC. Okay, so we will actually need to find AB cross AC. Okay, it's not part of the answer, okay, but I will need to show it. Okay, I will need to find AB cross AC. Okay, I will even need to show this one in the answer. Okay, but I will just plug in what I have over here. IJK. So AB, it is minus 1 plus 2 minus 1, minus 1, 2, minus 1. And AC, it is 0, 2, 2. So we can calculate this one. 2, 2, 4, 4 plus 2 I minus J, which is minus 2 J plus K will be minus 2. Okay, I hope I did not make any mistake. In any case, you can do the corrections. Plus 2j minus 2k. So over here what we will be getting the area of triangle ABC will be half magnitude of AB cross AC, which is square root 6 square plus 2 square plus minus 2 square. So this is what we will be having, 36, 40, 44. Okay, so this is the required answer, square units. So as you can see, it's very simple. Alright. Similarly, if we have to show, if there is a question like this, okay, so this completes. We can even do it with the dot product by using that formula which we had derived. Okay, but in case a question comes like this, are the points, okay, the same points A, B, and C. Okay, the same thing. Are the points collinear? Whenever you see this type of question, what will you do? You will calculate the same thing, area of triangle. If it is equal to 0, you will conclude that the points are collinear. If it is not equal to 0, then you can say that they are not collinear. The same thing, calculate the area of triangle ABC. If it is equal to 0, you can conclude that the points are collinear. If it is unequal to 0, then you can conclude that they are not collinear. So it's really simple. Okay, so that is all about applications, about the applications that we had done. Okay, so now we will still be doing some more applications. This one is from a trigonometric point of view. If you remember, question by using, I will set this one as a question, but it is still an application of the dot and the cross product. Prove that. Okay, number 1, sin A plus B. Okay, maybe cos A minus B. Cos A minus B, or cos A cos B plus sin A sin B. And number 2, sin A plus B, it's equal to sin A cos B plus cos A sin B. Okay, so by using vectors, we will try to prove it. Okay, we can even do it another way, but over here we are interested in the method by using vectors. Okay, I will try. I will do both number 1 and 2. Okay, I will give these two as exercises, cos A plus B. Okay, fill in over here, and similarly sin A minus B, fill in over here and do the proof. Okay, this one will be exercise that you can try on your own. Fill in and prove. Okay, I will be doing number 1 and number 2. I will be doing number 1 first. So over here, the main point is this. So over here we are using cos. Whenever we are saying cos, it means that we will be using the dot product. And for number 2, we are seeing the sine, so we will be using cross product. Okay, let us just do number 1 first. So we will need the angle A minus B. How are we going to need the angle A minus B? Okay, we can draw this Cartesian plane 0xy. So we can set this angle to be A. Okay, maybe OL. Let this whole angle be A, and let this small angle be B. Okay, and OM. So this angle will be A minus B. So this angle will be A minus B. So that is how I will get this angle A minus B. Okay, so the angle A minus B, it is the angle between OL and OM. So I will turn this one into vectors. Okay, I don't need this one anymore. Okay, so I will turn OL and OM into vectors. But here is the thing. I will not be using ordinary vectors. I will be using unit vectors. Okay, why am I using unit vectors? In fact, I can use unit vectors over here because it doesn't matter. Even if you increase the length of OL and if you increase the length of OM, the angle will still remain the same. Okay, the angle does not depend on the line segment, on the length of the line segment OL and OM. So that's why I can even choose OL to be of length 1. I can even choose OM to be of length 1. It still won't matter because all the angles will remain the same. Again, let OL and OM be unit vectors. Well, OL makes an angle A with positive x-axis and OM makes an angle B with the positive y-axis. So the angle between OL and OM is A minus B. Angle between OL and OM is A minus B. After this one, what I will do, okay, let me erase it. Erase this, okay, but I will redraw it again. Okay, let us just concentrate on this line OL first. Okay, so OL was like this and the angle was A. How much is the length of this line segment? Okay, the length of this line segment, it is A sine theta. And the length of this, the length of this line segment, it is cos A. And the length of this line segment, it is sine A. Because the length of OL, it is 1. Okay, because it is a unit vector, so this length, it will be equal to 1. So over here we will be having cos A, over here we will be having sine A. So what are the coordinates of L? The coordinates of L, it will be cos A and sine A. The x coordinate, it is cos A, and the y coordinate, it is sine A. I hope that is clear. Similarly for M, we will be having the coordinates to be cos B, sine B. That is what we will be having about the coordinates of A, of L and M. Okay, so this is what I will write. Now, coordinates of L is cos A, sine A. Coordinates of M is cos B, sine B, right? But now we are interested in the vector, so OL vector will be cos AI plus sine AJ, and OM vector, it will be cos BI plus sine BJ, right? So now we are interested in proving this equation 1. Equation 1, we will be using the dot product because it is cos. So now just find OL dot OM. Now OL dot OM. How much will it be? OL dot OM, we can easily write it as cos A cos B plus sine A sine B. And over here, if you expand this one by using the formula for the dot product, we will be having OL, OM, cos. The angle between OL and OM, it is A minus B. So we are done. Sine A, sine B. So that is why it is a unit vector. It is a unit vector. Hence, the magnitude is 1. We will be having the first formula, which is cos A, cos B, plus sine A, sine B. So this is what we will be having. Alright, so this completes number 1. Now we will do number 2. Okay, number 2, we just have to be a bit careful with the figure first, and then we will use the cross product. We will use the cross product because it involves sign. Okay, again, let OL and OM be unit vectors as in the figure. Okay, but over here we have to be very careful with the figure because we need an angle of A plus B. So OL, we can make it point in this direction. Okay, and OM, we can make it point in this direction. Let this angle be A, let this angle be B. So that is why this whole angle between OL and OM, it will be A plus B. Okay, so let OL, OM be unit vectors as in the figure. Angle L OX equal A, angle M OX equal B. So this is the angle, therefore A plus B is the angle between OL and OM. So this whole angle, it will be A plus B. Now again, we just need to find the coordinates. This one will remain as it is, cos A, sin A, because both of them will have to be positive. Both of them will have to be positive because they are in the first quadrant. But this point over here is in the fourth quadrant, first quadrant, second quadrant, third quadrant and fourth quadrant. So this point over here will be minus cos B sin B. Okay, so this is what we will be having. Now, okay, the coordinates, you can just draw the figure. Okay, we can easily conclude that OL, it will be equal to cos AI plus sin AJ, and OM vector, it will be minus cos BI plus sin BJ. So this is what we will be having. Now we will be using the cross product because over here we are interested in the sign of A plus B. Now OL cross OM. Because we are using the cross product, we will be using I, J, K. OL, it is cos A sin A, and K, it's 0. There is no K over here. Similarly, over here will be minus cos B sin B 0. So we can even expand this one by using the formula. It will be OL OM sin A plus B n cap. Okay, where n cap, it is a vector perpendicular to both OL and OM. Okay, and over here we can do the calculations. We will be getting cos A sin B plus sin A cos B. Okay, after expanding this determinant, we will be having this. So now what we can do is we can just take the magnitude of both sides and we will get the answer. The magnitude of this one is 1. So we will be having n cap equal cos A sin B plus sin A cos B. Okay, take the magnitude of both sides. Okay, magnitude of n cap will be 1. Magnitude of this one, it will be just sin A plus B, and magnitude of this one is just sin A plus this. Okay, so we are done. Okay, which is the required proof for number 2. Again, number 3 and number 4, you can try it on your own. If you have any problem, you can always send the message in WhatsApp. Okay, so that was also an application of vectors in trigonometry. So we can prove the different identities, trigonometric identities, just by using vectors. Okay, right now what I will be doing is another exercise, not necessarily an application of dot and cross product, but it will surely involve maybe the dot or the cross product. Question. Okay, find a vector in the plane of a bar ki plus j minus k in the plane of a bar and b bar. Okay, you can just write any vector over here, plus k maybe, and perpendicular to another vector c bar. Okay, again we can just give another vector, maybe 3i plus 5j minus 10k. Alright, so how will we do this one? This is actually what is going to happen. If you remember that vectors, they can always be arranged in this way, A and B, right? We can arrange it in this way, or because we can transfer them parallel to one another. What I mean is, we can, even B, it can be transferred in this way. It doesn't matter, we can do this one with vectors. We can either write it in this way, or we can write it in this way. It will still remain the same thing, as long as the vectors are parallel. Over here, B and this B, they are parallel. A and A, they are parallel. So we can either draw it in this way, or we can draw it in this way. It doesn't matter. As long as it suits us, it won't matter, because we can do that with vectors. We can move them around. So over here, this figure won't do for explanation, but I will explain it by using this figure. What happens is this. If we join this vector, and this vector will be A plus B by triangle law. If we are using the triangle law, this vector will be A plus B. Alright. So now let us see. MA, it is a scalar multiple of A bar. So that is why it will also be in the same direction as A. And B bar, and maybe N B bar, again it will be in the same direction as B. And this vector over here will be MA plus NB. What I want to say is this. If you are given two vectors A and B, if you are given any two vectors A and B, this vector, it will be in the same plane as A and B. Okay, because over here you can see A, it is in the plane of the board. MA is again in the plane of the board. B is in the plane of the board. NB is in the plane of the board. Even this vector is in the plane of the board. Okay, so this is what we will do in the plane of A and B, right? So I will write this. Any vector in the plane of A and B is MA plus NB. Okay, so this is what I am writing. Okay, so if you multiply it, you will be having MA will be MI plus MJ minus MK, and NB, it will be 2NI plus 2NK. So rearrange this vector, you will be having M plus 2NI plus MJ plus minus M plus 2NK. So this is the vector in the plane of A and B. Okay, maybe I will name it with Z. Okay, we can give any name that we like. Okay, but I am writing the letter Z. Now this vector, it is perpendicular to C. Now Z is perpendicular to C. So what can we have? always remember this. If you are seeing the word perpendicular, you will use dot product. And if you are seeing the word parallel, you will be using cross product. So z dot c is equal to 0. In fact, I will modify a question a bit. You find a unit vector. Okay, so z dot c, it will be equal to 0. So how much is z dot c? Z is this one dot c. It will be 3 times m plus 2n plus 5 times m minus 10 times minus m plus 2n. It will be equal to 0. Okay, so this is the question. So from here I have reached this line. Now we can even simplify this one. 3m plus 5m plus 10m, 8, 18m, 6 minus 20, 6 minus 20 will give you minus 14. So this is what we will be having. We can even simplify to 9m equal 7m. Okay. Now over here we just require a unit vector. Alright, we don't have to find all the vector, just one. So over here what I will do, I can just substitute a value for n, and I can just substitute a value for m. Okay, putting n equal to maybe 1, then m, it will be 7 upon 9. We can choose any value for n, and we can choose any value for m. It doesn't really matter. Okay, so this is what we will get. Hence, okay, z bar it will be ma plus nb, okay, which we can find out. Okay, you can do this. Okay, substitute the value for m, substitute the value of a, substitute the value of n, substitute the value of b, okay, and then find it out. But over here now we require the unit vector. Therefore required unit vector, it's equal to